Dear children, today starting with another application of derivatives, that is tangents and normals. So before we proceed, we need to be aware of the relation between a tangent and a normal and what exactly a tangent and a normal to a curve means. Now we are aware if any curve is given to us, there are infinite points on it, and we can always draw a line passing in such a way so that it touches the curve exactly at one point. So all these lines which will be touching the curve at exactly one point will be the tangents. Like in this figure you can see this point, this red line touches the curve at this point. So this red line is denoting the tangent to the curve. And how do we relate tangents to the derivatives? We know that derivatives of a function at a particular point, if you are finding derivative of a function, the function which is denoting say this parabola, then it has, as I told, it has infinite points. So there are infinite tangents which can be made to it, all the tangents inclined at different angle with the x-axis. Like this tangent is making an acute angle with the x-axis. So each tangent, because it is inclined at different angle with the x-axis, it will be having a different slope. So derivative of a function denotes the slope of the tangent at a particular point. So if we are talking about this tangent, then derivative of the function at this point will be denoting the slope of this tangent. And what about the normal? Normal to a curve is another line which is perpendicular to the tangent at that point. So this blue line is denoting the normal to the given curve. Now see, look at this figure. We have a curve y is equal to fx on which we have drawn a tangent at the point M and a normal to the curve. Now talking about the slope of this tangent, you can see it is inclined at an angle alpha with the x-axis. So if we define a slope of the tangent at this particular point, you can see the coordinates of the point M are x0, y0. So if we are defining slope of the tangent at this point, then looking at this diagram, the slope happens to be tan alpha. We can use the notation small m for it. So slope of the tangent small m is equal to tan alpha. Also, as we discussed just now, derivative of this curve, if we are differentiating this curve with respect to x, you can see the equation of the curve is y is equal to fx. So derivative of y with respect to x will be f dash x. Now if we evaluate this derivative at this particular point m, then dy over dx at x0 y0, or we can denote the derivative as f dash x0, then this will be also denoting the slope of the tangent at m. So we can say that dy over dx at this particular point is equal to tan alpha, or it is equal to m. Now as we have seen, normal is perpendicular to the tangent, so the product of the slope of normal and the slope of the tangent has to be -1. That means slope of the normal can be termed as -1 over m, which is slope of the tangent. So keeping that in mind, slope of the normal in terms of derivatives can be written as minus reciprocal of slope of the tangent at that particular point. You can see small m is equal to what? It is dy over dx at this particular point. So minus 1 over dy over dx reduces to minus dx over dy. Keep in mind we are talking about the slope at this particular point. Now when we know the slope of the tangent as well as slope of the normal and a point where they are being made, it is possible for us to write their equations. So equation of line you all have learnt in straight line in class 11th. Equation of line is written as y minus y1 is equal to slope of the line multiplied with x minus x1, where x1 and y1 are denoting the point on that particular line. Now if you see for this tangent, we know the coordinates of the point M. So if we are finding the equation of this tangent and the slope of the derivative we have evaluated at this particular point only, that is x0 y0, then slope of the tangent at this particular point can be defined as tan alpha that we said. So, or we can say dy over dx at x naught y naught. So now we are ready to write the equation of the tangent. So it will be y minus y0 is equal to slope. Slope of, when we are talking about the slope dy over dx, this is not a general term, okay, because we are talking about the slope of the tangent. Which particular tangent? The tangent which is touching the curve at x0 y0. So this you need to keep in mind. Dy over dx here is evaluated at the point x0 y0. In the same way, for writing the equation, so we were talking about equation of the tangent. You can see y minus y0 is equal to its slope at the given point multiplied with x minus x0. In the same manner, equation of normal can also be written, because we are finding the normal at the same point. So y minus y0 will be equal to slope of the normal at this point. Which point it is? Again, it is the point x0 y0 getting multiplied with x minus x0. So keeping these results in mind, we can now try to find the slope of certain lines called tangent or normal, and simultaneously let us see can we write their equations as well. Now, children, taking some examples from the topic tangents and normal. The first question is, find the solution of the tangent to this curve at the point whose x coordinate is 3. So for that, we will first differentiate it with respect to x. So differentiating y with respect to x, we get dy over dx is equal to thrice of x square minus 3. So this is the slope of the tangent to the given curve. Now its value will keep on changing depending upon the point at which the tangent is being drawn. Now for this particular case, we are making the tangent at a point whose x coordinate is 3. Now, so we will put it down. Tangent is drawn at a point with x coordinate 3. Now because according to the question they are saying you evaluate the tangent at this particular point, so we are finding dy over dx for x is equal to 3. So that gives us thrice of square of 3 minus 3. That means 27 minus 3, which is equal to 24. So the slope of the required tangent, that comes out to be 24 here. Okay. Now checking for the next one, it says find the slope of the normal to this curve for theta is equal to pi by 4. So first we need to evaluate a slope of the tangent. You can see both x and y are in parametric form. They are in terms of the variable theta. So first evaluating dx over d theta. So we are differentiating x with respect to theta. So on differentiating the right hand side, derivative of cos cube theta will be 3 cos square theta, and then derivative of cos theta will be minus sin theta. In the same manner, derivative of y with respect to theta, if we solve, it will be a times derivative of sin cube theta, which will be 3 sin square theta, and then derivative of sin theta is cos theta. Evaluating dy over dx, which will be representing the slope of the tangent, you can see most of the terms they get cancelled out while evaluating it, and let us see what it reduces to. Okay, now if we cancel out the common factors in the numerator and the denominator, you can see thrice of a gets eliminated, one of the sine theta and one of the cos theta, and finally we are left with minus tan theta. Now as we have to find the slope of the normal at theta is equal to pi by 4, let us first find dy over dx, which is slope of the tangent at theta is equal to pi by 4. So it will be minus tan pi by 4, which is minus 1. So slope of tangent is minus 1. As we are evaluating the slope of the normal, we know slope of the tangent into slope of the normal is minus 1, or they both are negative reciprocal of each other. So when I take slope of the normal, as I said, it is minus reciprocal of the slope of the tangent. So you can see it comes out to be 1. So slope of the normal is 1. Now checking for another one. See this, it says find the points at which the tangent to this curve is parallel to the x-axis. So evaluating the slope of the tangent first by differentiating y with respect to x, you can see it reduces to 3x square minus 6x minus 9. Moreover, what is being said? It says tangent is parallel to the x-axis. Now, what is the slope for the x-axis? Slope of x-axis is 0. And because tangent is parallel to x-axis, that means slope of tangent will be equal to the slope of x-axis. So equating these two, you can see slope of tangent just now we have evaluated 3x square minus 6x minus 9, and slope of x-axis is 0. Now simplifying this equation by taking 3 common and cross multiplying 3, it reduces to x square minus 2x minus 3 is equal to 0. Now factorizing the given quadratic equation, you will see the two linear factors that we get are x plus 1 and x minus 3. So this means either x is minus 1 or x is equal to 3. Now because they are asking us to evaluate the required points, so we need to find the y coordinates of these points which have x coordinates either minus 1 or 3. So when x is minus 1, you can check from the curve what y will be. Y will be cube of minus 1 minus 3 times square of minus 1 minus 9 into minus 1 plus 7. That comes out to be minus 1 minus 3 plus 9 and plus 7. That is minus 4 plus 16. So it is 12. So when x coordinate is minus 1, y coordinate is coming out to be 12. In the same manner, we can check for x is equal to 3. When x is 3, y will be cube of 3. That means 27. Then minus 3 times square of 3. Square of 3 is 9. So 9 into 3 is again 27. Then minus 9 into x. X is 3. So 9 into 3 is again 27 plus 7. So one of these two numbers, they get cancelled out. Plus 27 minus 27. And y is minus 27 plus 7, which is minus 20. So therefore required points means where the tangents were parallel to the x-axis. So one of the point is having coordinates minus 1 comma 20, and it is 12 not 20. The other one is 3 comma minus 20. So first one is minus 1 comma 12. Second one is 3 comma minus 20. Now taking another one. See, it says find a point on this curve at which the tangent is parallel to the chord joining these 2 points. Okay, let us first find slope of the chord joining the given points. What are the given points? 2 comma 0 and 4 comma 4. So we know if 2 points are given to us, their slopes, if coordinates are given to us, their slope can be evaluated by subtracting y coordinates divided by the difference of x coordinates. So this reduces to 4 by 2, which is 2 only. Okay. And for slope of the tangent, let us differentiate y with respect to x, because y is equal to square of x minus 2. So in differentiating both the sides with respect to x, we get twice of x minus 2. Now given condition is tangent is parallel to the chord. Now if the tangent is parallel to the chord, this means slope of tangent should be equal to the slope of chord. So equate these two and find the required point or points. So slope of tangent is twice of x minus 2 and slope of chord is 2. That on simplification gives us x minus 2 is equal to 1, or you can say x is equal to 3. Now when x is equal to 3, let us see what y will be. So when x is 3, we can check for the y coordinate by substituting it here. So you can see y is equal to 3 minus 2 whole square, which comes out to be 1. So therefore required point is, so on the curve there is one point 3 comma 1, where when you will make the tangent, it will be parallel to the chord joining these 2 points. See the next one, children. It says about finding the equation of tangent line to this curve which is perpendicular to the given line. We know when two lines are perpendicular, their product of the slopes comes out to be -1. So let us first evaluate slope of the given line. Okay, given line is 5y minus 15x is equal to 13, which can also be written as 5y is equal to 15x plus 13. Now dividing both the sides by 5, the equation reduces to y is equal to 3x plus 13 over 5. So we can easily make out what is slope of the line. So slope of the line is coefficient of x, which is equal to 3. Now finding for the slope of tangent to the curve. Slope of tangent to the curve can be obtained by differentiating y with respect to x. So this is dy over dx. Let us differentiate the given equation with respect to x. Now dy over dx comes out to be derivative of x square, which is 2x, minus derivative of 2x, which is 2. That of 7 is 0. Now as we know, tangent is perpendicular to the line. Therefore, we can say slope of tangent into slope of line. This will be equal to -1. So this is the equation we are going to solve. Now we have seen slope of tangent is 2x minus 2 and the slope of line is 3. So this is equal to -1. Now expanding the left hand side, which comes out to be 6x minus 6 is equal to -1, and solving it, we see the value of x reduces to, shifting 6 to the right side, it becomes positive. So 6 minus 1 is 5. So x comes out to be 5 by 6. So that means the tangent is made at a point whose x coordinate is 5 by 6. Now if the x coordinate is 5 by 6, we can evaluate the y coordinate. Y coordinate will be square of 5 by 6, that is 25 over 36, minus twice of x, which is 5 by 6. So that becomes 10 over 6 plus 7. Taking LCM, y reduces to, you can see the common denominator can be made 36. So y is 25 minus 60 plus, if we multiply 36 with 7, it comes out to be 252. So this entire term divided by 36. And on simplification, this gives us 217 over 36. So both x and y are known to us. We can write the equation of the tangent now. Therefore, equation of tangent at 5 by 6, 217 over 36. It will be y minus the y coordinate is equal to slope of the tangent. See, if slope of the given line is 3, the slope of the tangent becomes -1 over 3 because they both are perpendicular to each other. This multiplied with x minus 5 over 6. Now we need to simplify the entire expression. You can see this will reduce to 36y minus 217, and on the right side, if you see the common denominator here comes out to be 18. if we take LCM here, the denominator will be 18. With 18 you can cancel out 36. So it will be minus 2 times 6x minus 5 here. Now expanding the right hand side and shifting all the terms to the left, we already have 36y, and this will be minus 12x. Bringing it to the left, we get plus 12x. Then the constant here is minus 217, and shifting this constant, which comes out to be plus 10 to the left side, it will become minus 10 equal to 0. That means our equation is 36y plus 12x plus minus 227 is equal to 0. Now one from the normals. See this one, it says find the equation of normals to the curve, given curve, which are parallel to this line. So again we will be equating the slope of normal to the slope of the line because they both are parallel. Quickly writing for the slope of line. Firstly, what is the line? It can be written as, if we write it in the form y is equal to mx plus c, then it will take the form y is equal to minus 1 over 14 times x and then minus 4 over 14. Okay, so slope of this line is minus 1 over 14. And what about the slope of the normal? For that we will first find slope of the tangent, which can be obtained by differentiating y with respect to x, which reduces to 3x square plus 2. So this is slope of the tangent. So this implies slope of normal will be, slope of normal is minus dx over dy. So writing for minus dx over dy from here, so it comes out to be minus 1 over 3x square plus 2. Now normal is parallel to the line, so we can write slope of normal is equal to slope of line. Slope of normal is equal to slope of line. Equate both and then find the value of x. Now slope of normal is minus 1 over 3x square plus 2 and slope of the line is minus 1 over 14. So this on simplifying can be written as 3x square plus 2 is equal to 14, or we can say 3x square is equal to 12. That means x square reduces to 4, or we can say x is equal to plus minus 2. So possible values of x are plus 2 and minus 2. Now when x is 2, y comes out to be, it can be obtained by substituting x here. So y will be 8 plus 4 plus 6, that is 18. Fine. And when x is minus 2, y will be minus 8 minus 4 plus 6, that is minus 6. Okay, so 2 points we have got, 2 comma 18 and minus 2 comma minus 6. We'll write equation of normal at these 2 points. So equation of normal at, let us first take the point 2 comma 18. Okay, so it will be y minus y1, which is 18, is equal to slope of the normal. Slope of the normal is same as the slope of line. So it is minus 1 over 14 times x minus 2. Simplifying this, we get 14y minus 18 into 14, that is 252. So this will be equal to minus x plus 2. Or we can shift x to the left hand side and it comes out to be x plus 14y, and shifting 2 also to the left side, it becomes minus 254 is equal to 0. So this is one of the equation of normal. We have another point. So at that point also normal can be evaluated, its equation. So that other point is minus 2 comma minus 6. The equation will be y plus 6 is equal to minus 1 over 14 times x coordinate is minus 2 here. So x minus minus 2, that makes it plus 2. On solving this, we get 14y plus 84 is equal to minus x minus 2, which on simplification further gives us x plus 14y plus 86 is equal to 0. So you can see two possible equations of normal we could find, because there were 2 points at which if the normal was drawn, it was parallel to the given line.